Okay, let us continue with the transmission section. Okay, we discuss about determination of gear ratios, achievement of high maximum vehicle speed. If you want to have a high vehicle speed, combined with a good acceleration and economy over the whole speed range of a vehicle, requires a system of gearing that allows the engine to operate at the speeds at which it develops its best performance. Okay, so first of all, if you know the engine performance, you need to give what vehicle speed that is appropriate for the engine or for the vehicle. So by knowing the maximum torque, maximum power, then you have to adjust your gear ratio also to get the optimum performance. Maximum engine power, torque, and also economic in a engine versus power versus RPM curve. You can see which power at which RPM. So this characteristic have to be studied first to get the maximum engine power, torque, and economy, and all occur at different engine speed. It is not at a single engine speed. There's several engine speed. So this make the task of matching the gear ratio difficult, especially when variable operating condition. If you have variable operating condition, for example, you are climbing a hill and then you go to a flat surface or curve, or rainy day where the surface is full of water, and this is considered a variable operating condition, and driver demands have to be taken into account. So this one, all these conditions have to be studied before you okay. Setting the numerous gear ratio takes into account the engine requirement to suit a given operating condition. This is some of the engine requirement. For example, if the operating condition you want a maximum vehicle speed, then the requirement is you have to have a maximum engine power. So for the speed, you need the maximum engine power. But if you want to have maximum acceleration, then not the engine power. The important thing you must have here is the engine torque, maximum engine torque. And if you want to have a maximum traction, then you also need the maximum engine torque. And lastly, for the maximum economy or the better fuel consumption, so this one, if you see usually in the engine curve, you will see that engine at mid-range speed, usually the mid-range of the engine speed will be the most economical condition, and under light load with a small throttle opening. So engine must be at mid-range, where the load of the engine is not so big, and usually for this condition we just need a small throttling, or you just need a small amount of fuel to be used to burn or to make the engine moving. So this kind of condition must be understand before you choose a gear ratio. Okay, today the type of engine fitted to a light vehicle generally requires a gearbox. You need a gearbox that gives 4 forward speed and a reverse. This is usually a common one. That is 4 different forward gear ratio in addition to on reverse gear. Reverse gear usually you only have one ratio, because it is not usually used. Okay, this gives a reasonable performance to suit most driving condition other than economy, and normally needs extra ratio for a fifth gear. So if you want to have a economical condition, then you will add another fifth gear or the top gear, as we understand from the previous videos or previous chapter, and that is higher than a conventional top gear. Usually you will have one input with input will be 1 and output will be less than 1, but for a top gear the input is less than the output. Okay, it should be noted that high gear is one that has a ratio with lower numerical value, that is ratio 1:1 is the higher than the ratio 2:1. So the lower gear, the greater is the reduction between engine and road wheels. This means that for a given engine speed, the road wheel speed is lower. So usually engine speed is higher than road wheel speed, but for top gear only, the engine speed might be lesser than the top speed of the wheel. Maximum vehicle speed, this is achieved when the gear is set in top and the throttle is held fully open. You will give the full air fuel ratio. Air fuel insert to the chamber, combustion chamber. To minimize friction losses in the gear that is used for most of the time, a ratio of 1:1 or direct drive is chosen to be top gear. But consequently, the setting of top gear is really the choosing of the final drive ratio to suit the diameter of the road wheel and the engine characteristic. Okay, I will show you the graph, the consideration that have to be made to ensure that the vehicle can attain a high maximum speed, and it shows the balance between the power required and the power available. So this data are given by brake power curve of the engine. You will see the graph, and for the latter they are obtained from calculation of the power needed to overcome the tractive resistance of the vehicle when it's moving along a level road, so the flat road. Okay, you see here, you can see the power required to drive vehicle usually will be a curve going up like this. So for example, you can see a road speed of 200 km per hour, you need about 100 kilowatt of the engine power. And power available to drive the vehicle, you can see if engine speed of 5000, then this is the brake power, and here will be the maximum power of the engine, and usually below that you will find that the maximum torque that the engine can produce is below the engine speed at maximum power. So it depends on engine, what kind of engine. Okay. And then you can see the curve show balance between power available and power required. So this one is the power required and this one is the power available. When you show it in the same graph, you see here, this is the power available curve, and this one is the power required curve. So when we overlap it, there's a area here where showing that the power required is below than the power available. So if you take the difference here, you will have this curve. So this is the power available for acceleration. So you can use this power for acceleration if you have a suitable gear ratio. So this is how the engineer study to get the vehicle maximum speed or the vehicle maximum acceleration.